Hello guys, welcome to our another lesson. We're doing fractions and decimals. So I want us to first know how to convert a fraction into a decimal and vice versa. In this case, I've got four fractions here. I've got a half, fifth, quarter, and a 3/4. Now I want us to convert these fractions into decimals. That is a concept which is mostly asked in exams. So first of all, we've got this half. So our number one, I'm going to say, what you have to understand here is that if a fraction is structured like this, this is called a division. So this is simply 1 divided by 2. It is equal to 0. If I say it's equal to 0 here, it's still incomplete. What we still have to do is to add a small 0 there. Once you add a small 0 there, you introduce a comma here. So it's now 2 into 10, that's 5. This is your answer. We do the same with 1/5, that is your number 2. Your number 2, that's 1 divided by 5. So it's 5 into 1, it's equal to what? 0. Then I put a small 0 there. Putting this small 0 will automatically introduce a decimal point there. Then 5 into 10, that's equal to 2. That is your answer. So it's still the same with those other two. It's still the same with those other two. Fine. These are called terminating decimals. We have two types of decimals. The first one, this one, is called a terminating decimal. What is a terminating decimal? A terminating decimal is a decimal that can end. If I say it can end, it means that you simply divide it. It's not recurring, so it's called a terminating decimal. Then we've got what we call a recurring decimal. Recurring decimals are always given correct to 3 significant figures. So I'll give you an example here. I have 1/30. I'll put it as my number 3. 1/30. So it's 3 into 1, that's 0. Then I'll put a small 0 there, which will introduce my comma. 3 into 10, that's 3. It's remainder what? Remainder 1. I'll put another 0 again. It's 3 into 10, 3. This will be happening continuously. Remainder 1, 0. 3 into 10 is 3. So since it is recurring, it's going to be 0.3333333. So in this case, in order for you to indicate that this is a recurring decimal fraction, you are going to put a small dot there. This dot indicates that this is a recurring decimal, right? So that is a recurring decimal. This is a terminating decimal. I'm doing this so that you understand some questions that you encounter in the exam that are going to specifically mention that convert this fraction as a terminating decimal fraction or convert this fraction as a recurring decimal fraction. Let me show you some examples from some question papers that I have here with me. Okay, here I've got June 2015. Number 1A, the question says, express 5/16 as a decimal fraction. The second one, as a percentage. Let me show you how to do this one. So, it's number 1A. Number 1A is 5/16. So we say is equal to, in this case, it's 16 into 5, that's equal to 0. Then I put a 0 there, which will automatically introduce a comma. Now it's 16 into 50, I'll get my 3. Remainder 2. Then I'll add a 0 there. Then 16 into 20, I'll get my 1. Remainder 4. I put a small 0 there. 16 into 40, that's, I have my 2 there. Remainder 8. Then I put my small 0 there. 16 into 80, that's equals to 5. So I have expressed this fraction as a decimal. And this type of a decimal is called a terminating decimal, just because I have arrived to an end here. So it's ending. Then the second question, which says convert this fraction into a percentage. It's just the continuation of this one. You just multiply this by what? By 100. So it's simple. Your item 2, converting 5 over 16 as a percentage. You just take it from your answer. Since you know that a percentage is always expressed up to what? Up to 100. So it's simple. 0,3125 times 100. So we are going to have, our comma is going to move 2 times just because we've got 2 zeros there. We've got 1, 2. So that's going to be 31,25%. That is your answer. That is your answer. So this is a typical question that I have. I've got the other one which specifies based on a recurring decimal. Which specifies on a recurring decimal. Fine. I've got June 2016 there. Express 7 over 30 as a recurring decimal fraction. Express 7 over 30 as a recurring decimal fraction. Fine. With this question, it's still the same. The concept remains unchanged. So I'm doing number 2b. Express 7 over 30. 7 over 30 is a recurring decimal. The question already has specified it for you that this will come out as a recurring decimal. Now you are supposed to be in mind that how will you indicate that this is a recurring decimal? So simply we are going to say is equal to 30 into 7, that's 0. Then here, instead of introducing a 0 there, you cancel this 0. You want to do away with what? With bigger numbers, just because this is paper 1, you won't be using any calculator. Therefore, by cancelling this 0, you're going to introduce a decimal point there. So 3 into 7, you're going to obtain your 2. Remainder what? It's remainder 1. Then we add your 0. 3 into 10, that's 3. It's going to be recurring 3. Since we already have what? 3 significant figures here. So we're going to put a small dot there. This dot indicates that this is a recurring decimal. This dot indicates that this is a recurring decimal, right? Then I'll take you to another concept of converting decimals into fractions. So I've got this number. Number 1, I've got 0,25. If I say convert this decimal into a fraction, we count the number of decimal places. If we are removing commas, we use tens, hundreds, thousands. The reason being that every 0 will move a comma, then everyone will not change the number. So in this case, we're going to use 100. So it's going to be equals to 0,25 over 100 times 100 over 1. Here, we are going to obtain this 100 is going to move this comma 1, 2. So we are going to have 25 over 100. Then we reduce this fraction. 25 into 25, 1. 25 into 100 is 4. So automatically our answer is equal to quarter. This is your answer. The following question that you might find, let me try to divide here for clarity. I'll divide here. I'll have 0,125. So in this case, how many decimal places do I have? Is 3. So which number that contains 3 zeros is 1000? So it's equal to 0, 1, 2, 5 over 1000 times 1000 over 1. So in this case, automatically you're going to obtain 125 over 1000. Then as I reduce here, 125 into 125 it's 1, 125 into that one it's 8. So your answer is equal to 1 over 8. Those are the typical questions that you find that will require you to obtain your answers that will be in fractions. So I've got another example here. It's from June 2014, which was a decimal, but it was requiring your answer to be left as a fraction. So it's number 1A, item 1, June 2014, paper 2. The question was saying evaluate 0.85 minus 0.6, leaving your answer as a fraction. So in this case, you were using your calculator, then your answer was going to come out as 0.25. Fine. Then you convert this 0.25 into what? Into a fraction. I think we have done it before there. So your answer is going to come out as what? 1/4. That will be your final answer. That is the first approach of dealing with decimals. So I'll take you to the second approach. Okay guys, so as for now, we are now rounding off decimals. But before we round off decimals, there are some concepts that you are supposed to understand based on decimals and significant figures. There are some various concepts that you're supposed to understand based on decimals and significant figures. First of all, what you're supposed to understand is that decimal places is the number of numbers that are found after the comma. So I'll give you this first example. Number 1, 0.25213. From my definition, decimal places refers to the number of numbers that are found after the comma. So in this case, how many numbers do you have after the comma? Is equals to 5. So this number is equal to 5 decimal place. Bear in mind, this is the shorthand for what? For your decimal place, that's DP. Then the second concept that you're supposed to understand, I'm done with decimal places. I'm moving on to significant figures. I'll give you this same example, number 2, 0.25213 is equal to, in this case, this number is equal to 5 significant figures. Get the definition of significant figures right. Significant figures refers to the number of non-zero digits that are found within a number. In this case, how many non-zero digits do we have? Is 5. So is equal to 5 SF is equal to 5 significant figures. Then number 3, if you are doing significant figures, a 0 is considered to be significant only if it is found in between non-zero digits. For example, 0.202, that's equal to 3 SF. This 0 is considered, but this one is not considered because from the definition of significant figures. Then I'll take you to number 4. A 0 is considered to be significant if it is found after non-zero digits and after a comma. So I've got 0.0000320. So this is equal to, these zeros are not considered. They are insignificant. We start to count where there is a non-zero digit, and then this 0 is going to be considered. The reason being that there is a comma there, so it's equal to 3SF. Then number 5, I've got this one, 2000. This is equals to 1SF. These zeros are not considered. Why are we not considering them? The reason is being that there is no comma here. So it's only 2 that is a significant figure. Then the difference comes if we introduce a comma here, number 6. I would say 2,000. Now this is 4 significant figures. Why do I say so? Because there's now a comma here. So it's equal to 4SF. So what you have to realize with the significant figures here, we consider a number to be significant if there is a non-zero digit, and then zeros are considered to be significant if they come after non-zero digits and provided there is a comma, or they are found in between non-zero digits. So that is the basic principle with significant figures. And what you also have to understand is that this is one of the very important topics in maths, just because it comes as part of the instructions from most of the question papers. It comes as an instruction from most of the question papers. So I'll show you from the instructions of our question papers, that we have here. There is our instruction. Decimal answers which are not exact should be given correct to 3 significant figures unless stated or otherwise. So what you have to understand is that if you don't understand decimals, it means that within your answer sheet you are still going to be losing some extra marks just because you don't even know that what does this instruction imply you to do. So this is one of the critical topics that you are supposed to understand, guys. So I'm going to take you to the next level of our decimals. So firstly, this was our first stage. I'm taking you to the next level. Okay guys, as I'm taking you to the next level of decimals, I want you to understand some units that are used in decimals. For instance, this is 342. So these are hundreds, these are tens, these are units. Then from this is our comma. What I want you to understand is that soon after the comma, we have got our tenth, so that's 1/10. We've got our 100th, so that's 100th. We've got our 1000th, that's 1000th. That's how we express such numbers. So now I want us to start rounding off decimals. I'm going to be using question papers to answer such questions. So here is the other question that I have here with me. It's June 2016, number 2. June 2016, number 2. We're given express 31,095 correct to the first answer. The first answer is supposed to be in 2 decimal places. The first answer is supposed to be in two decimal places. So that's 31.095. So we're giving the first answer in what? In 2 decimal places. What you are supposed to understand here is that you will never answer a question unless if you understand that the question is in what decimal places. So in this case, where you considering decimal places, bear in mind decimal places refers to the number of numbers that are found after the comma. In this case, the question is in what? Is in 1, 2, 3 decimal places. Then we are required to convert it to what? To 2 decimal places. So we're going to count 1, 2. Then we look at the third digit. The third digit is supposed to give here if it's 5 and above. If it's below, we automatically remove it. In this case, this 5 is going to give a +1 there. So here is going to be a 10. Then this 10 is going to give a plus 1 there. So we are now, here is going to become what? A 0. And then here is going to become a 1. So our answer is going to be 31.10. This is your what? These are your two decimal places. These are your two decimal places. You see? Then we are moving on to significant figures. This is our item 2. We want to answer this question pertaining to significant figures. So we are going to say 31.095. It is equals to how many significant figures are there? We've got 1, 2, 3, 4, 5. Fine. We want two significant figures. So it's going to be 1, 2. We look on the third one. The third one can't give 2, 1 there. So your answer is going to be just 31. That's 2 significant figures. This is your answer. This is your answer. So that is our June 2016. Then let me check on this 2009. State the number of significant figures in the number 0, 000 320. Here you are just supposed to state how many significant figures do you see there. It's equal to what? 1, 2, 3. So it's equal to 3 significant figures. Then the other question here, I've got my compressed question paper. In this case, it's write down the value of 7 in 0,072. We want to apply this concept. We want to apply that concept. So in this case, this is our 2005. It's November 2005, number 2A. We want to write down the value of that one. So in this case, it's 0,072. There is our guideline. This is your unit. Soon after the unit, it's your 10th, it's your 100th, it's your 1000th. So you are asked to write down the value of 7. So we've got two formats of writing this 7. It's either we can say 700th in words, right? Or this is your first format of writing. Second format of writing your answer might be 7 over 100. We've got two formats of writing your answer. It's up to you. It's up to you on which format do you choose to use. It's up to you on which format do you choose to use. Then I've got here June 2015 here. I've got June 2015 here. Express 0,0978 correct to 2 decimal places. Then it be correct to 2 significant figures. Fine. So let me try to do this. Alright, let me try to answer this one. It's a June 2015 number 1A. Given this number, express it correct to 2 decimal places. First of all, how many decimal places do we have here? It's 1, 2, 3, 4. So to 2 decimal places is equal to, so you count 1, 2, we look at the third one. So in this case, this 7 will give here, we're going to have a plus 1 here, that's 10, then plus 1 there. So your answer is going to be equal to 0.10. That's to what? To 2 decimal places. That's to 2 decimal places. Then item B requires me to convert the same number, correct to what? To 2 significant figures. Correct to 2 significant figures. First of all, how many significant figures are there? We've got 1, 2, 3. So from my answer, I'm supposed to obtain how many? 2. So I'm going to count 1, 2. Then I'm going to look at the third one. It's going to give here a plus 1. So my answer is going to be 0.098. This answer is to what? To 2 significant figures. This answer is to 2 significant figures. So those are the basic principles. Let me give you the last one. I've got the last question here. It's November 2003, number 6. It says express 49.9973 correct to 4 significant figures. So it's number 6A here. 49.9973 correct to what? To 4 significant figures. First of all, we have to determine how many significant figures do we see there. It's 1, 2, 3, 4, 5, 6. So our question is to 6 significant figures. So let's convert it to 4 significant figures. We count 4 digits. 1, 2, 3, 4. So we're going to look at the 5th digit. What you have to understand here, we've got triple nines. So if we give it these nines, they are going to be converting to what? 10, 10, 10 up until 2 plus 1 here. It's going to be 5. So we want to obtain 4 numbers. So it's going to be 50.12. This is your answer correct to what? To 4 significant figures. That is our answer. So that is the end of our phase 1 approach on what? On decimals. We're going to meet on our second lesson where we will be adding, subtracting, multiplying decimals and so forth. So this is the end of our first concept. This is the end of our first concept of decimals.